that I'm doing something rather different to the usual sort of thing. Here I have the column stalks for the Vauxhall Corsa steering column. Now these are designed to work with Canbus, so that's why there's only 3 wires for all the various functions, different wiper speeds, intermittent and squirt and everything. 3 wires, and the same with the other side. I think it's got flash and left and right indicators, blah blah blah, all that type of thing. Now, the way I suspect this works is that it's a string of resistors. Because although it's Canbus, and I must admit that I've got this from elsewhere on YouTube, so thanks, and also I'm not sure what's true, but anyway, let's go with it for the moment. A string of resistors, and we've got ground, and we've got a tap point, if you like. So resistor 1, 2, 3, and then ground. After some further investigation, this is how I understand these stalks to work. So using the indicator stalk as an example, it does appear that the brown and yellow striped wire, this one, which is connected to a yellow wire here, is a common point, and one of the other wires, in this case black and white, works on the indicators. And when you move the indicators, that's the neutral position, that's showing 1.5, 1.4 kiloohms. As I move that down to left flashers, I'll now get 477 ohms, back to 1.4 kiloohms in the middle, and then right flashers 150 ohms. That's quite a big difference between 150, 1500 and what was it? 470 ohms. So those are the that's the example purely for the flashers. And when I look at the so if I flash the switches, so I'm flashing the headlamps now, as you see, nothing happens at all. And if I go on main beam, again, nothing happens. However, if I go to the other wire, the brown yellow is common. If we go to the other wire, the reverse is true. So again, we're left and right flashers. So we've got about 1500 ohms, left and right flashers, not affected at all. But if I flash the headlamps, we now get 490. And if I go for main beam, I get 150. So this is the principle. So we have one wire which is common, and 2 wires, other wires. One is for up and down on the indicator stalk, and the other one is for forward and back on the indicator stalk. So this is what I think is actually happening in the circuit. So we have a chain of resistors, and when you alter the stalks, they're choosing between different parts of that chain of resistors. And one is for indicators, and the other one is for flash, dip, main, what have you, on the other side. They're completely independent of each other. Although I will say that if you measure between, for example, here to here, there is actually a circuit going around the top, so don't get deceived by that. The important thing is to get a 5 or 12 or whatever voltage you're using at one end. The other end needs to be 0 volts, and you measure the voltage in between depending on the position of the stalk. And that's how it works. Now the wipers stalk, which is this one, have actually got slightly more functions on due to the availability of rear wash wipe and so on. But the principle is exactly the same. 3 wires, one of which, what the brown yellow, same colour, is common, and then we have black blue and black white, which do the other functions. So that's the resistance switch, or the resistance selection switch, that is what these stalks are actually doing. So by understanding what the resistances mean, we can build a circuit and a little computery thing which is capable of measuring those resistances and doing something accordingly. And here in this table I've summarised my measurements of all the functions on the indicator switch, with various resistances depending on the function, and on the wiper switch again various resistances based on the functions, and those we'll be using. I'm at the next stage, or a couple of stages actually, I think, since last time I spoke, and I've got here some relays, some light bulbs, my Arduino that's running some code, and a voltage driver, or relay driver I should say, which gives the Arduino just enough oomph to drive the relays. And I'll show you what I'm doing. So I've got here a variable resistor, and all it does is it goes to 0 to 100k, I think, ohms that is, and according to the setting, the Arduino is doing different things. So imagine, if you will, this is two switches, or two poles of a switch. When I say switch, I mean modern switch, which is actually a resistor chain, and I'm just going to turn it to different values. So at the moment it's basically 0, so it's fully to one side, and as I turn it up, and eventually, I'm looking at the code on the screen, which I'll show you in a second. So there we are, my first light bulb has come on. The Arduino told the relay driver to drive the relay, and the relay made the wiring work, so the light bulb came on. Now you might think that's not ever so extraordinary, as I've got a volume control driving a light bulb. No, it's really not that simple, and watch out for the clicking noises, by the way. So I'm going to carry on turning it up. Notice how the brightness doesn't change. So one went out and the other went on, and we keep on going to a different resistance value, which is all configurable on the code. Now we've got another different one come on, and keep going, and now we've got a nice orange one. I chose these light bulbs because I could solder onto them, by the way, because I haven't got enough sockets to connect them into. Keep on going, and finally got the last one on, and if I go all the way over to the other side, they all go out again. So let's just do that again. So I'm going to turn from 0, I'm going to keep turning continuously as much as I can. 1, 2, 3, 4, 5, nothing. And that's all done with code, which I will try to demonstrate. Now ideally I would have found a way of uploading video, but I haven't actually found a way to do that just yet. So I'm going to point you at the screen of my laptop. Now we'll find out if you can see anything on here. Actually, I'm going to see if I can make the font bigger. Hold on. There now. So I've changed the font size, and on the left hand side you should see a series of numbers floating past, which are measurements of resistance. It's a simple voltage divider, which basically means if you apply voltage across two or more resistors, you can calculate what the voltage at any point between each resistor actually is, and therefore thereby calculate its resistance if you don't know what it is by measuring the voltage there. So it's a kind of a voltmeter in a way, but a voltmeter with a calculation attached to it. If I twiddle the knob here, you should see that number changes. We've got 1600, now it's down to 16,000 I should say, now gone to 800 and 250, 120, 80 something, 70 something, $40 something, 30 something, and then 20 something, it all goes off again. And that's all configurable. You may not be able to read exactly what's going on here, but perhaps you will recognise there's some numbers in here. For example, R2 being more than 20 and less than 40. Or is it between 40 and 80? Or is it between 80 and 150? And so on and so on. And because those numbers are completely configurable, I should be able to use that to decide, and that's what this digital write thing here is, going digital write, tell pin 2 to go low, or tell it, or pin 3 to go high, and so on and so on. And that's basically how it works. So by setting on choosing the resistance values, I can get the different lamps to do different things. Replace the variable resistor with the stalk instead, and that's operating on the indicators side. And in neutral position, you can see maybe it's reading 1460 something ohms. Now it's important to note, of course, that the actual figure doesn't actually matter. What matters is being able to tell the difference between different figures. So I'll just calibrate this thing to make the right switches work. So we're going to go left, and already you can see I've got a orange light on, which is handy, showing 479 ohms. If I go the other way, 150, that's obviously not quite right because it's kind of flicking between two different ones. So I just need to fine tune the numbers on the screen aren't quite stable. So I just need to choose some different numbers to work with this switch. But the important things to note are 150 ohms, and that is right hand indicators, and left hand indicators is 470. So I'll just choose some different figures to suit that. And so by choosing suitable values, I've done this. Left indicators, not flashing yet. Right indicators. There you go. So who says you can't use, I don't know what kind of switches you call these? Canbus switches, but without any Canbus. So yeah. And for my next trick I shall get them flashing, but maybe not today. And finally, well, not finally, but finally in this element of this sub-project, I've added some delays in, and I've added some looping in, and we get this. Left indicator, right indicator, and all, of course, this is done without a flash unit. All of the flashing is done on the Arduino, which may or may not be possible to replace with a smaller device. It's already fairly good. And how it's doing it is it's reading the resistance between basically the pins of this, the leads of this switch, and having measured the resistance, it's deciding what to do. And in this case, let me show you. Let's make the fonts bigger again. So I hope you can see that we have the kind of resting resistance at 1460, 70, something or other. And when I go left, it changes to 480, and we get one bulb flashing. And when I go right, it goes down to 150. And now we have the other bulb flashing. So that's it. Now, as you can imagine, this is just one function, i.e. indicators. I haven't attempted yet to do flash, dip, wipers and all of that stuff. And in order to possibly do all that, there will have to be lots of more wires connected. I suppose flashing is one of the more complicated because it does flashing rather than just being on, as it were. But a lot more sensing, a lot more measurements, and a lot more wires. And I run into questions about whether I've got enough connections available. But if it turns out that I haven't, I can use more than one of these things. So one for the stalk, one for the wipers, for example, one for the indicators wouldn't be unreasonable at all. So yeah. Now XF Motorsports, I think he did say it's really easy, and in fact, of course, he's right. But it's only easy when you know how to drive or code a little bit of Arduino. But what it does mean is that these modern indicator stalks, you don't need to go to the level of using Canbus. All this is doing is measuring resistance values and deciding what to do with it. The Canbus stuff, well, okay, that's a future, but for this simple level of left, right, squirt, wipe and all of that, Canbus isn't necessary, but we can use the modern stalks, and that's great news. And this morning I have got further functions. This is what I had yesterday. But I've now doubled up on the resistance meter with an extra resistor comparator thing. I'll have to go into some of this in a bit more detail, but I've basically duplicated the mechanism which detects the resistance, because there's 3 wires here. So the resistance is being measured first for the indicators between this wire and this wire, and for the flash functions between this wire and that wire. So obviously it's 2 different measurements, and therefore we need 2 of them. So I duplicated that, added extra bulbs on, and so this is now flash, which is highly configurable. So we have left, right and flash. And interestingly, if I hold flash on, it continues to flash like an indicator. That may or may not be quite the correct behaviour, but it might be. So yeah. And then I've got to do dip beam, or main beam I suppose it is actually. And that also works, and that also flashes, which isn't quite right. What I want it to do obviously is toggle, so it stays on, it goes on until it's switched off. But I'm, 90% of the way there with this thing. And the same process of course will apply to the wiper stalk, which has got exactly the same type of 3 wires out and a bunch of functions as a result of those. So we'll end up with a copy of this whole system in all probability. Possibly I could do it all on one, but that will depend on the number of pins I've got and what size of box I want to put it in and so on. But yeah, this is very promising indeed for anyone wanting to use a common or garden Vauxhall Corsa indicator switch or wiper switch on their Vauxhall Corsa power steering column, which of course is a very popular mod that people have been doing for a few years now. And after a considerable amount of further research and effort on my part, which in actual fact proved to be pretty simple in the end, if I'd only known. It was extremely simple in the end, if you knew. I now have the indicator and flashing stalk fully working. So left indicators, right indicators, flash and dip, which doesn't latch, so you have to, it toggles. And believe me, that was the most difficult part to sort out, but sort it out I have done. And there we go. So now we'll do the wiper stalk, which hopefully will be a lot quicker to do than that was. And now, if you can imagine for a moment, this is slow speed windscreen wipers, fast speed windscreen wipers, squirter. We have this using exactly the same approach as before, and this time the device here is measuring the resistance between the brown-yellow wire, the black-grey wire, and between the brown-yellow wire and the black-blue wire. And with a good deal of jiggery-pokery, which most complicated part was the intermittent wipe, we have this. So first of all, a single stroke wipe. It's not quite right, is it? Right, this is intermittent. This is intermittent. So this is the wiper motor being switched on for a moment. Of course it goes around a cycle and coming back. So this is intermittent every few seconds. That's probably a bit on the fast side to be honest, but so intermittent, just slow, so it's on, and then we have fast, and then we have squirt. And there are other functions on this stalk for the rear wipers which I'm not using, but in principle other things could be done with that. So then we have fast, slow, intermittent, and something not entirely right there. Yeah, there's something not 100% correct. I shall just have to be back in a moment. But the principle is very much there. And yeah, Mr. XF Motorsports, on which this work is based, but who didn't provide any information about exactly what he'd done. Yeah, quite a bit of fiddling around. It wasn't quite the same as being terribly easy, but it's one of those things that once you know, then you can do it. But the essence of it and the main part of it is this thing here, which is measuring resistance between the various wires on the two stalks. Unfortunately I haven't got enough light bulbs to demonstrate all the functions at the same time, but you've seen the indicators working earlier on. So I've just rigged up both stalks at the same time. I haven't quite got enough lamp bulbs to demonstrate everything all at once, but both of these are wired into the same Arduino, and if we look over here you can see the numbers going up the screen there, which are the 4 resistance measurements, which there's two variable resistors in each of these over here, and they vary depending on the position of the stalk. So there it is doing what it's doing, and if I change the position of one of the stalks, you can see we've now got a different figure here, and so on and so on. There we go, and the same with the other stalk. So you can see the figure changing. That's the essence of it. Of course, I've slowed it all down. It runs much more quickly, too quickly to see on the screen in reality. But anyway, that's the principle. So I'll now go back and I'll speed it back up to normal speed and you can see everything happening. So here we go. And this is the wiper side. So we've got intermittent, and we have slow, fast and squirt, and that's it. There may be some tweaking that I need to do to get all the settings exactly right, but more important than that, I need to get this rough and ready breadboard circuit into something that I can install in the car, and if I need to, I can alter some of the settings. But that's it. That's basically how to use some Vauxhall Corsa modern style indicator stalks, and this same process no doubt can be applied to virtually any recent cars indicators, and probably other types of switches as well. I'm carrying on finessing the operation of this system for the wiper stalks, and one of the things that was missing was the hazard warning lights. And it would be a bit of a shame, wouldn't it, to have a completely separate circuit rigged up just to do hazard warning lights, considering that these relays over here are not on-off things, they're just relays. So I thought about it for a while, and then I realised, of course, although the stalks themselves aren't capable of putting hazard warning lights on because of either a certain resistance value or a different one, what I can do is create a resistance value which is not one that is possible from the stalks, and I can do this with a short circuit. So there we go. I'm quite pleased about that. So I don't need a separate hazard warning circuit. I just need a switch that provides a short circuit on one of these sensing wires to, well, 5 volts in this particular case, so that's nice. After waiting several days, I've received these socket things, which are equivalent to the sockets you get for integrated circuits to plug into a circuit board, so you don't actually have to solder the pins of the circuits themselves. Now I've actually already done that. This is the relay driver that is directly soldered, but if I'd had this before I probably would have used this. But the Arduino is got twice as many pins on it basically, and that's even worse. So although there's not a socket that you can use for an Arduino Nano like this, what you can get is these things, what they're called header sockets or something, and luckily I'll get 2 of them, one for each side of the Arduino. You can put them in like that, and so therefore this can be soldered, or those 2 things can be soldered into the circuit board, and the Arduino will then remain removable, which will be useful especially when testing. So that's what I'm going to do now, and take my circuit board to the next level when I can test it and hopefully non-destructively confirm that it actually works. So yeah, I shall solder those in, and then I shall take the Arduino, which I now can't do. I can't take it out very easily because it's all pushed home. But I wanted to make sure it was on there so that I could get the right space between. Anyway, whatever. Yeah, I shall quickly solder that on. Right, that should do it. And now I shall be able to remove the Arduino from the board, probably with the help of a screwdriver, to provide a bit of leverage. Oh no, it's coming even. There we go. Alright, so that's what it looks like, and effectively that's my socket for the Arduino. 2 strips. 15 pins on each side. So yeah, it's quite a lot of pins really. And it all appears to be in the correct place, which is nice. So now for testing. Now ready to move on. Well, in fact I have moved on from this breadboard setup, which I've used up to now, to this circuit board setup. And yeah, it looks kind of similar in actual fact, and that's the idea of it. Turn the thing the other way up with the resistors for the resistor chain in here and in here. So yeah, very similar layout. We've got the relay driver chip there, we've got the relay driver chip here, but also we've got a voltage regulator which takes a 12 volt feed and converts that to 5 volts and powers the Arduino. So the Arduino is not currently plugged into the computer, although it may have to be for further testing, but at least it's well, it's got a little red light on it and nothing's gone up in flames. So basically what I've done is I've just transferred the circuitry from this breadboard to this circuit board, which mimics the internal connections of the breadboard. And one further thing I did do was to deliberately cut the track that runs across the top of the board and put a diode across it to prevent damage if I should happen to connect it up to the power supply, or indeed the car, back to front, which yes, I did do that. Shan't do it again though. And finally, excuse the dripping noise coming from above, I'm in the conservatory. And finally, I now have the circuit board integrated with all the wires, and believe me, there's a lot of wires and a lot of ways to get this wrong. But now it's working, so I have, as always, left indicators, right indicators, we have flash, we have intermittent, we have slow, we have fast, and we have squirt, and I think we also have beam. Yeah, beam. So there we are. I'm sure there's probably some fine adjustments I can do, but it's working. Oh, and one other feature we also have, and it'll have to be done by an earth to something using a switch, obviously. If I earth this wire here, we have hazard lights, and of course that is using a function that is not even present on the stalks. It is just there on the circuit board. So I'm pretty pleased with that. Pretty pleased. And I think I can now stop this sub-project. The sub-project is kind of done. It now needs to be installed. And yeah, that'll be the next stage. And I'll just mention or point out the USB connection from the computer is no longer working or no longer connected. It is simply running from this power supply over here. But nevertheless, I can go back in and change the programming if I want to. So this sub project is over.